Okay, so how do we add sensors to a Raspberry Pi? Well, first we need to talk a little bit about what sensors actually are. Sensors come in many different shapes and sizes, and they generally add the capability to measure an environmental factor of some type. So for instance, the simplest possible case is this device here. This is a light sensor. You can see there, you've got a little light sensitive resistor which measures how much light is being received at that particular component there. So that resistor will change the voltage that is being passed through this sensor here, and the device that's controlling it, like this Raspberry Pi, can measure that voltage. Except actually a Raspberry Pi can't measure voltage on its own. It needs a special analog to digital converter device to be able to measure voltage. Similarly, we have a line finder there that has these two little photodiodes, I think. We've got a simple switch here which will tell you if there's voltage or not. There's a knob here which is a potentiometer, and as you change the position of the knob you have more voltage going through that potentiometer. Here's another example. This is an infrared light sensor. So instead of looking for visible light, this looks for infrared lights like you might see from a remote control, for instance. And here's a moisture sensor. So you place these two probes into soil, for instance, and you can measure the amount of moisture by the amount of electricity that passes between these two probes. So those are some analog sensors that measure voltages. Here we've got a couple of other sensors. So this is a 3-axis gyroscope. This is a 3-axis gyroscope, and you can see it's got a chip here. That's the gyroscope actually. And this is a digital sensor, so it's measuring a lot of things at the same time. It's not necessarily just making a voltage with a resistor, it's doing a bit more. Similarly, here we have an accelerometer here. You see there's another one of these chips in the middle there, surrounded by other smaller chips. That inside that chip is the mechanism to measure the acceleration in the X, Y, and Z dimensions, so 3 dimensions simultaneously. So we're not going to send out 3 voltages, we actually use a digital signal to communicate those numbers. And over here we've got a distance sensor. This is an ultrasonic distance sensor. This sends out a pulse and waits to hear the pulse back, so this is kind of a bit different. It is sending digital pulses, clicks, and then receiving those digital pulses back by using its microphone inside there. And by comparing when it's sent and when it received those pulses digitally, by using numbers, it can calculate the distance to any surface that it's pointed at. And finally, here's a digital knob. This is an encoder, and it makes clicks every time you turn it around, and you can keep on turning it around for a long way. So this is a device that can measure a number of clicks in a particular direction, and unlike the analog knob, it continues infinitely around. So there's a number of different sensors. We have some that are digital, that communicate through signals, and some that are analog. These ones can communicate through voltage. So digital signals over here, numbers and data, and voltages over here, continuous voltages that need to be measured.